Nuclear pharmacy. Nuclear pharmacy versus radiopharmacy. The difference. Both terms are used interchangeably. Radiopharmaceuticals are prepared, stored, and dispensed. Pharmacists. A radiopharmacist is a regular pharmacist who has been trained to handle radiopharmaceuticals. Centralized nuclear pharmacy. Evaluate the cost effectiveness of the preparing, distributing, and dispensing radiopharmaceuticals. Advantages of centralized nuclear pharmacy. Readily available radiopharmaceuticals. Technologists save time. Reduced radiation exposure. Less probability of radioactive contamination. The design of a nuclear pharmacy. Clean air environment with exhaust fume hoods fitted with filters. Appropriate airflow, which is a laminar flow hood for sterile environment. Separate areas for compounding and dispensing. Radiation protection of personnel. The design of a nuclear pharmacy continued. Workbenches should be made of stainless steel or wood covered with laminated plastic. Floors should be made of removable tiles or covered with rubber matting because of spills can be easily removed. Storage areas should be built of thick concrete walls, and storage safes should be lined with lead. The essential equipment is a dose calibrator, a chromatography equipment, radiation survey meter, which is the Geiger counter, an area monitor, which is a cutie pie, pH meter, light microscope for particle sizes, NALTI detector coupled to a multi-channel analyzer. It identifies the contaminants in radiopharmaceuticals. Lead-lined refrigerator and freezer to store certain cold kits and radiopharmaceuticals. A hot water bath. Dry heat even well-type NALTI counter. And L blocks. The USP 797, United States Pharmaceutical Convention, USP, and FDA set a standard in 2004 for preparation of compounded sterile preparations, CSPs. Compounded sterile preparations, or CSP. Radiopharmaceuticals are considered low-risk CSP, compounded from sterile components in closed, sterile containers with a volume of 100 ml or less for a single dose injection, or not more than 30 ml taken from a multiple dose container. PET radiopharmaceuticals are treated separately due to the nature of compounding and standards addressed in the USP 823. Operation of a nuclear pharmacy. Receiving radioactive materials, preparation of radiopharmaceuticals, the QC tests of radiopharmaceuticals, storage, dispensing, radioactive waste disposal, infectious waste disposal. Receiving and monitoring radioactive packages. The institution needs to have a RA materials license in order to be authorized to possess and use radioactive materials. Packages should be monitored within 3 hours if delivered during normal hours or within 3 hours from the beginning of the next working day. Survey must be done on the surface and at 1 meter of the package using a Geiger counter. Receiving and monitoring of radioactive packages continued. Readings should not exceed 200 milliroentgens per hour at surface and 10 milliroentgens per hour 1 meter away. Light tests must also be done on the package of the surface. The limit is 0.003 microcuries per 300 centimeters squared, 6,600 centigrades per minute. All data must be logged. Preparation of the radiopharmaceuticals. All preparations should be carried out under a laminar flow hood and under aseptic conditions. Personnel should work behind lead barrier shields and gloves should be worn. Technetium-99m activity is eluted from the moly generator daily early in the morning. Preparation of the radiopharmaceuticals continued. Total technetium-99m activity should be added to a kit vial depending on the number of patients and their scheduled time of study. When preparing kits, avoid allowing air into the vial. After reconstitution, every kit label contains a control number, product name, concentration, date, time of calibration, and expiration. All label information should be recorded. Quality control of radiopharmaceuticals. Each radiopharmaceutical must pass a quality control test before being dispensed. These include sterility, pyrogen, and radiochemical purity. The quality control of the radiopharmaceuticals continued. Technetium-99m labeled radiopharmaceuticals are prepared daily and have TLC tests performed to determine labeling efficiency. Colloidal and macroaggregated radiopharmaceuticals must behave their particle size checked. Repeat that sentence. Colloidal and macroaggregated radiopharmaceuticals must have their particle size checked. Storage. Radiopharmaceuticals need to be properly stored as indicated on package insert to avoid being degraded by light or temperature. Technetium-99m macroaggregated albumin must be stored at 2 to 4 degrees Celsius to prevent bacterial growth and denaturation of proteins. Storage continued. To prevent production of Bremsstrahlung radiation in high Z materials such as lead, P32 labeled compounds, and SR89 stored in low Z material containers such as plastic. What do these two isotopes have in common? They're pure beta emitters. Dispensing. Prescription or hospital requisition made in writing by physician. A verbal order can be accepted in a centralized nuclear pharmacy. Most doses for nuclear medicine studies are standardized. A list of all of those doses should be readily available in the nuclear pharmacy. Before drawing up a dose, the volume can be calculated through the concentration and date/time of calibration. Dispensing continued. Dosage drawn should not deviate more than plus or minus 20% from the prescribed dose of administration. Each time a radiopharmaceutical dose is dispensed, the following should be logged: the date and time of dispensing, patient's name and identification number, name, quantity, and control number of the radiopharmaceutical, name of individual dispensing the dose. Pediatric doses. Doses must be adjusted for children due to the different factors such as body weight and surface area. Several different methods of calculating dose for pediatrics. Body surface area calculation is the most accurate. Radioactive waste disposal. Generated waste that is radioactive needs to be disposed according to the following methods: decays and storage. It's most common due to the common use of radionuclides with short half-lives. Released in the sewage system, incineration, and burial in a landfill. Radioactive waste continued. Institutions which receive unit doses from a centralized pharmacy can return the syringes and vials to the vendor. How should the label be? Oh, no, it doesn't give an answer. Records must be maintained to include date of storage, amount of storage and disposed, date of disposal, meter used to monitor, and name of the individual who is disposing. Infectious waste disposal. State regulates that infectious waste must be disposed of by incinerated, chemically treated steam, or sterilized ionizing radiation. Infectious waste should be stored in puncture-resistant, leak-resistant bags with International Biohazard symbol. The end.